Welcome back, everyone. And today we will continue with Terraform stuff, and we will focus on testing. Because if you remember from previous videos, we decided that it's a good idea to just straight away deploy to dev environment, and then with a little bit of a manual process and getting to deploy straight to production with only test being done if someone would read through the plan and approve that plan to be deployed to production. And while this is good enough in terms of not deploying something unexpectedly to your production environment, so all of those changes they are checked by one person manually, we still don't know if the code itself is good or not. And once again, if you remember from the beginning of that series of Terraform 1 or something, we had a little bit of a validation, but let's just jump in the code and I will explain it over here. So what you can see, it's the pipeline as it was before. The only change that I did for now is I renamed it to Terraform 104 because it's important, of course. And then let's have a quick reminder of what we had before. And before, for the dev stage, we just checked out the repository as usual. Then we say that we want to set up Terraform and use a specific version of it. And then here we have a little bit of an interesting detail. And I will not scroll too much, so please ignore this bit. But then we have three steps that we want or that we had. And here we do the basic validation and testing of the Terraform. And the first test that we perform is to run the Terraform format check. And this is just pretty much like a linting of the Terraform. And if you don't have all of the equal signs aligned nicely in your file, so someone saves the file like this, Terraform format will fail. And let's just show it quickly here. So clear. And if you run Terraform format check, and I need to Terra. I need to learn how to type Terraform format check. It is saying that this file is not good enough and it needs to be formatted, and you can run the Terraform format to actually fix the issue locally, and then all of the equal signs over here they are aligned and the Terraform file looks nicely and it is easy to read. But it has nothing to do with the validity of the Terraform code or how good it is. It's just that it looks nice. And because of that, we need to run the second test, that is Terraform validate. And in that case, it just tries to check if the Terraform code is actually, let's call it, executable. So if it can be run or not. And just to show it as an example, we can change this provide region, or let's take instance type 1. So obviously it's incorrect property. And then we will run Terraform validate locally. And it will fail, first of all, because I don't have a state. But additionally, it is actually failing with this argument of type Terraform instance type 1 is not expected here, and it will have a hint of how to fix it, but that will work only for the most obvious issues. For this one, it is a little bit more in depth, and it actually checks what is provided, it tries to have it, and because of that, you need to run the Terraform init before you run the Terraform validate. So all of the provider details and information about how to use Terraform, it needs to be available in advance. But once again, it has nothing to do with tests, more like unit testing of the code or to have security checks. And that's what I wanted to suggest as a next step, and that's what we are going to implement in this video, is to have some sort of a basic security check. So you don't want to deploy your infrastructure when you know that there is a critical vulnerability available. That actually plays nicely into the DSOM requirements. And if you would want to know what is DSOM and why you might want to care about it, I have a couple of videos about this on my channel. I will link them in the description for you. But long story short, there is a very nice open source tool that is called Trivy. And you can find it on this address. I will link it as well. And basically, how it is said, it's an all-in-one open source security scanner. I, on my channel, mentioned Trivy a couple of times already, and I am very, very, very pleased and in love with this because it can scan your Terraform code, it can scan your images, it can scan your application code, and do a lot of things for you, starting from the generation of S-bombs all the way to the vulnerability scanner for your code. So it is great. It's just one tool to rule them all, which is once again easy to learn and understand, and it is very easy to use as well. There are actions available for the GitHub Actions that you can use. So there is a Trivy action like this, and you can find it in the ecosystem link over here with the CI/CD and just how to use it. You will have a link to this action, and here in the README you have a nice explanation on how to use the Trivy for all types of scanning. But if you come from a different background, or if you want to run Trivy locally the exact same way as you run it in your CI/CD pipeline, what I recommend you to do is to run it as a Docker container. And that's what I have over here with a Trivy check action that we run. And we just use it as a Docker run. Then what is very important is that we mount a volume for that container. And for the volume, we just run it from the whatever we have over here that is available in the /dev folder on that container. And then we actually scan it with a configuration, so it scans for misconfigurations of the code, and we feed what directory it should look for, and it will scan this Terraform directory where we mounted our volume. Then interesting bit over here, it is specifically for CI/CD pipelines. You can specify that if there would be a severity of critical, then it will exit with a code 1. So everything that is non-zero exit code from the action perspective, it is considered an error, and the whole pipeline will fail. And I can quickly show you how it looks like over here. So when we run locally with the same command, let me find it over here. Yep. Let me clean it again. And when we run docker run volume, I just mount a local folder into the Terraform and I scan for the config. So without the exit code or what severities we care about, it can say that actually there are a couple of things that are not good. And if you scroll up, you will see that actually performed a couple of tests, and they were two failures, and it can find that there are two of the high issues in terms of the security, in terms of the configuration of my Terraform code. I'm not going to fix it right now. It is not that interesting for the sake of the presentation and the demo, but it is possible to copy the details about those issues and check about them. So for example, for this one, AMDS v2, you can copy this link, and if you would navigate to it in your browser window, you will see that it just wants you to enforce HTTP tokens, and it has a code snippet on how to do it, and pretty much it wants this metadata option to be included into the code. And if we would do that, so let's quickly copy and show how it is done. Anywhere in here, and if we will rescan the thing with this change to them to have the metadata options, now we will have only one of the failures, and the other tests are good, and we still have a high priority issue. Now, because I have it set as critical only, the high exception is not picked up as a error, and that's what I have checked into the code base right now. When you run it from the pipeline itself, the Terraform step, the dev one where we made those changes, it is still green. We can go into the Terraform code, into the pipeline execution code, and see that there is a Trivy check step that was executed. And over here, the output of it would be exactly as we had it locally. And there are two of the misconfigurations found. Where is it? Sorry. No, because of the critical severity being filtering out, uh, actually we don't pick anything, and the result is all good. There are no misconfigurations. But if we would change the code slightly, so we can put as critical and high, and those can be copied from here, or if you want, you can specify the configuration of the tree yourself. And then when we will git and git commit. Okay, I definitely need to learn how to type and git push. And that will be pushing to my 104 branch. On that branch, I don't have any automatic builds, but still from the previous video, if you remember, we enabled the manual dispatch and we can run the Terraform 104 branch, the workflow from this branch. And in a second, what we will see that it picked up because I said so, and it will try to run the code. So it will run the Terraform init as we saw in the pipeline. Then it will check the format, which would be good, hopefully, and validate. I hope I haven't messed up with this copy paste. And finally, we have the Trivy check, but this time we have included the high issue, and it actually finds this single issue that we still have. You have the same output from here, and the whole workflow, the whole pipeline actually fails, which is good because we don't want to automatically deploy any bad code to our dev environment. And that's a gate, that's a test for it. So to wrap it up, I highly recommend you using Trivy for all of the security and configuration issues that you might have. And this example on how we can implement it for Terraform and not pass any bad code into your dev or production environment. Because if someone would look at the code, they might not know that there are some issues with security. But this check will add some level of protection for you. So happy coding!